Hi guys, welcome to this tutorial. I have opened the script start version 1 in the scripts directory, and I've already set the format to the correct size, which is 1600 by 900. So here's a shot we're going to be working on. It's 45 frames of Iron Man shooting his hand beam things, and we've been given the task of removing the markers on the green screen. There's 9 of them, and we're also going to extend the green screen in the top of the screen right. So plenty to do. So this being my first tutorial, I shot this footage to kind of emulate what you might expect to get as a first paint task when you enter the industry. It's quite similar to the sort of shots that I got when I first started. It's not a difficult task, but it's not a super simple task. There are definitely some challenges. But I think you'd be expected to be able to do this sort of marker removal task at a minimum when you enter the industry. So I thought this would be a good place to start. And obviously we'll look at some more advanced level tasks in future tutorials. For this tutorial, I'm actually going to show you multiple methods of removing tracking markers. We're actually going to more or less use a different method of marker removal for each marker. The reason being is I've watched a lot of tutorials that deal with marker removal, and what you'll typically see is they'll teach you one method of removing markers, which is great, and it'll work really well in the context of that shot that they're demonstrating it on, but in the context of another shot, that method may not work at all. So what I want to show you is that there are many ways to deal with marker removal, and it's going to be very helpful to sort of have these different techniques in your arsenal, because you never know what unique problems you're going to face in any given shot. Obviously, in a real world context, you're going to use one or maybe two methods that give you the best result, the fastest. But for the purpose of this tutorial, we're going to take the long road, so we learn various different methods, and we're going to talk about the strengths and weaknesses of each method and discuss the context in which they're going to be useful, and likewise when they're not going to be so useful. So it's a good idea whenever you get a new shot to spend a bit of time thinking about what's going to be required and the challenges that you're going to be facing. Marker removal, or any sort of object removal, is always going to be made more difficult when things that need to be preserved are moving in front of the things that you're removing. Obviously, for the purpose of this tutorial, I shot the footage so that this would be the case. So we're going to need a method of bringing Iron Man back over whatever cleanup we do. And after that, we're going to need to fix the edges where the markers are showing through, such as here. And in doing all of this, we really want to change as little as possible of the original plate. That's really one of our key considerations as paint artists, and a big part of this tutorial is going to be illustrating workflows geared towards altering the plate as little as possible. This is the original plate that I shot here, so as you can see, I've actually already done a bit of work on this already. I moved some markers around just for the purpose of just so I could cover everything I wanted to cover in this tutorial, and I've changed the helmet so it's enclosed now, and I've continued up the neck area here. And I just did this just because the original plate looked awful, and I didn't want you guys to have to look at this for however long this tutorial is going to go for. This was really just a quick job I did on this. But in future tutorials, I plan on creating some shots for you guys where we'll be doing this sort of work, where we're doing sort of paint fixes or alterations to suits. It's something I've been doing a lot in the past 6 months on the latest Spider-Man film, where Marvel wanted his suit to be really smooth and sort of perfect, kind of like his suit is his second skin. And the practical suit that Tom Holland wore on set was really not perfect, and in some cases it was far from perfect. It had like creases and folds and bumps all over it, and so in a lot of the cases they would actually just do a full CG replacement, and that would be for a number of different reasons, not just because the suit looked bad. And so it'd be our job to just paint Spider-Man out. But if possible, they would opt to use the practical suit, so it would be our job sort of to make the suit look beautiful, which was very challenging work that required some pretty intense patching and tracking and warping and all sorts of things. And I'll definitely be doing some future tutorials on that because I think it's going to be really helpful to know how to do that sort of work. I didn't know how to do that sort of work when I first started in the industry because at the school I went to, we just didn't really cover that sort of work in any real depth. And I went to a really great school in Auckland called Media Design School, which I recommend to anyone in New Zealand. But there's just so much to learn in Nuke that there's just not enough time. So how my school worked is you'd learn something, you'd do a quick exercise or a short project, and then it's sort of on to the next thing. And in saying that, I think it's totally up to the student too to be continuing to learn at home, and that's really, really important. It's as important, I think, as what you're learning in class. And so that generally means a lot of practicing and watching a lot of online tutorials, which I did. And there's a lot of great tutorials out there, but there are so many things that I had to quickly learn on the job that I never found in any tutorial. And some of the stuff is sort of unavoidable. There's always going to be lots to learn whenever you start a new job, like learning the studio pipeline and the tools and everyone's name. But as far as the work goes, the ideal scenario would be that you feel confident that you already have the knowledge to do the work to the standard that's required. And so that's going to be my main goal of this tutorial series. It's number one, to show you guys some really awesome techniques that I've learned, and number two, to give you guys a really good idea of what work in the industry is like, and sort of to help you prepare as best as possible. Basically, it's my goal to make the tutorial series that I wish was available when I was a student, stressing out about getting a job and whether or not my skills were up to scratch. So anyway, back to the shot. So now that we're clear on what needs to be done, the first thing I generally do before anything else is I denoise the plate. Removing the grain from the plate is a critical first step because if we don't, in no time at all we're going to destroy the grain, and I can demonstrate that with a simple transform node. So the plate within this Roto node is being transformed subpixely by 0.5 pixels in X and Y, and as you can see it has softened the grain considerably. The reason for this is something called filtering, and I think I'll go into that in more detail in a subsequent tutorial, but for now just know that under the default settings, whenever you transform something subpixely, it's going to cause a reduction of quality and you're going to lose detail. There are things you can do to counteract this softening, such as adjusting the filtering algorithm or by using a sharpen node. But in the case of grain, this should really be avoided. And the reason is, we need the grain in our output to match the grain in the plate that we're given. If we work on a grain plate, soften and then destroy the grain, and then try to regrain, it's going to be almost impossible to get the grain matching the original grain. So our workflow, which I've demonstrated in this little setup here, is going to be to degrain the plate, to work on the degrain plate, to isolate the areas that we've worked on with an alpha, regrain just those areas, and then the rest of the plate is going to remain untouched. So we're just going to use the Nuke denoise node to quickly write out a denoised plate. The Nuke denoiser works best when you can point it to an area of the plate that is a flat color with little or no texture, so that the only detail in the analysis area is the grain itself. That's going to get the best result. Also, the darker the area, the better, because the darker the area, the more intense the grain. So we're just going to have it analyze this area of the plate, and we're going to have to lock the analysis region, because with the camera move, we don't want it reanalyzing every frame and analyzing different areas, which is going to give us a different denoise result depending on what frame we're looking at. We're just going to leave the rest of the settings as default, and we're going to render out a denoise plate. So just render that to a new folder, it shouldn't take too long, and then we'll read it in, and that will be the plate that we're going to be working on. Okay, cool. So we've denoised the plate and we've read it in, so let's get started. First off, let's deal with the top screen right here. We're going to extend the green screen up to cover this area up here. I guess it's a little bit of a pointless task because you'd think that a quick garbage mat could get rid of this, but then again his arm does come quite close to it, In any case, we've been asked to do it to make the job easier for the artist that's pulling the key, and it's a good idea to do what you're told, especially when you're new to the industry. So a very useful node when patching green screens and blue screens is the IBK color node. This node is basically a clean plate generator that is used in conjunction with the IBK gizmo keyer. We're not going to be using it to pull a key, but we can use the IBK color node to patch this area, and we'll probably even use it later to deal with some of the markers. So let's set the screen type to green, and you can see that it's already doing its best to remove all the non-green elements and create a clean plate. But we're going to want to play with the settings here, so let's set the size down to 1 so we can see what it's doing. And we don't really want to see any of the remaining red or orange that's in the plate, because what these controls are going to do is they're basically using these values and sort of dilating them outwards. And we don't want these values that you can see here in the red channel to be contaminating the result. So let's set the size to 1, and we can do an erode here, which is going to erode in 1 pixel increments. And if we set a value of say 3 or 4 pixels, that's going to remove those red values. And then we can either increase the size like so, or we can use the patch black function, which is going to remove the black areas basically from the image. The size parameter is going to essentially blur and unpremult the plate. So you could even produce a similar result just with a blur and an unpremult node. But let's not create unnecessary nodes. Let's just use the IBK color and increase the size nice and big, and that's going to be our solution for patching this area of the plate. Now, in the spirit of only changing what we need to change, we're going to key mix this back over our denoise plate, and we're going to use just use a quick Roto as a mask. So create a key mix node. If you haven't used a key mix node before, it's basically similar to a merge, but it's a bit different in that it's not going to consider the alpha from the alpha channel from A. It's going to use the alpha from the mask input, premult with A, and then over B. So it's basically replace B with A based on the mask. So let's do a quick Roto. The most important frames are the frames where the hand comes close to our patch. So let's just go to that frame and we'll draw the shape on that frame. So keyboard shortcut E is going to create a feather, and so we want the paint to blend nicely with the original plate. So a feather will do that nicely. And then we're just going to go step through the frame range using the arrow keys and just set a few quick keyframes. Cool, so we have our roto, we've animated it off the frame, and now if we play through the footage, we can see that that's been dealt with pretty quickly and effectively. So let's just label what we've done, and then we can move on to the markers. For the first marker, let's just do this guy here. I think we're going to use the clean plate that we generated here from the IBK color, and we're going to use a roto shape to basically reveal a portion of this plate, just where the marker is. So this is similar to the first method of how we extended the green screen, but on this occasion we're going to use tracking information to drive the animation of the roto shape. So let's get started. Let's start off by hooking up a tracker to the denoise plate, and we're just going to create a track just right on the tracking marker, and we'll just hit track. Cool, so that did a good job, and we have the tracking information that we need. Now we could go ahead and use the same setup before and use a key mix, but instead let's just hook up a roto node. And then looking back at the original plate, let's create a shape around the tracker using an ellipse shape. So holding Control and Shift when you create an ellipse means it's going to make the center of the ellipse the point where you first click the mouse, and it's also going to constrain it to be a perfect circle. And then let's just give it a feather. And then before the Roto node, let's just create a shuffle node and let's get rid of this alpha channel that the IBK color created. So we have our Roto outputting an alpha, and now we're going to pre-multiply by RGB. Now we need to link it to the tracker. So click on the Transform tab, and in this case we can either link the tracking data to the root or just to the shape. Let's link it to the shape. Now open up the Tracker tab and go to the Transform tab. Make sure the reference frame is set to the frame we drew the shape on, which is frame 1. And now we link the translation data by holding the control key and left click on the animation menu and dropping it onto the translation data of the Roto shape. And now our Roto shape should be animating correctly. Now let's just create a merge node and merge that over our denoise plate. And there you have it. Now just because it's working on the first frame doesn't mean it's working throughout this frame range, so let's play it and see how it looks. So it looks okay here. A better way to quality check is to look in the red channel, because any remaining marker is going to be a lot easier to spot in the red channel. Actually, an even better way to quality check this is to use the tracking data that we already have to stabilize the plate around the marker. So let's duplicate this tracker and let's hook it up to the B stream. And in the Transform tab, let's set the transform type to Stabilize. Stabilizing is an incredibly effective way of doing a quality check. If you can nullify any extraneous motion, it just allows your eye to notice even small errors. It's also very useful when you're quality checking Roto. So for the purpose of keying, I'm sure this is fine, but we can see that it hasn't quite 100% taken care of it. We can see that during the camera move there's some red values still coming through, and we can make this more clear by increasing the contrast. And we can see that on this frame here, our Roto shape is actually not large enough and is not covering the marker fully. So to deal with, let's step back a few frames to when the shape is okay and set a key. And now let's step forward to after the bad frames and set another key on, say, frame 37. And then let's go back to the worst frame and make our shape larger. Cool, so that looks a lot better. So yeah, this marker's been taken care of. So let's talk briefly about our workflow and how it is we're going to be isolating just the paint that we've done, so that at the end of this we're going to have basically just one master alpha. So at the end of each stage of our work, basically we're doing our paint off to the side here and then using an alpha channel to isolate just the areas that we're bringing back over the plate. So here's the alpha channel for the green screen extension, and here's the alpha channel for our first marker removal. And so while we work, we're going to be combining and preserving these alpha channels down a separate stream. So once we've finished all the paint, we're going to have a correct alpha channel that we can use just to isolate the paint that we've done. And so we can use a channel merge to do that. And we're going to be continuing this process at every stage of our paint. Cool, so let's do this guy for the second marker here. And for this one, we're going to utilize a feature in the Roto node that allows us to do an offset reveal. So let's create a Roto node and hook it up to our B stream. And let's create a roto shape around this tracker. Now we want the Roto node to be outputting RGB, and we want it to output an alpha as well. So next we go to the Shape tab, and we're going to set the source to background, so it's going to be displaying the RGB of the background, the BG. Now we go to the Clone tab. Here we can transform the source, which is the BG, and we can use the transform control to transform it. So in what direction do we want to transform it? Well, let's look through the footage. So through these frames here, his arm is going over the tracker. So you can probably see that if we're sourcing from this sort of area over here, we're probably going to end up revealing more of his hand, which we don't want. So we really want to source, I think, from the right of this tracking marker. And I would say this area up here looks like a pretty good area to source from. So let's set that up and see how it looks. So go to the Clone tab, and let's transform it by like minus 50 pixels in X, and then the same in Y. So that looks like it's done the job. And once again, we're going to need to apply some tracking data to this roto shape. So let's track this marker. So once the hand comes over the marker, let's stop the track. And if the track has gone crazy and you need to delete the keys, just go to the last good key and then hit this button up here to delete the keys going forwards. And now let's step forward a few frames and just manually place the tracker. And the rest should be fine to track. Now let's link the transformation data of the tracker to the transformation data of the roto shape. And just remember to go back to the first frame, the frame that we drew the roto shape on, and link the tracker from that frame. Cool, so as we did before, let's duplicate the tracker and set it to stabilize so we can quality check this cleanup. And it looks pretty good. So now that we're happy with that, we need to figure out how we're going to merge this with our B stream. It's not outputting an alpha because it's outputting from the background and there's no alpha here in the background. So let's create a shuffle node up here and add a full alpha to it. And now we need to pre-multiply it by RGB. Cool, so now we have our patch that we can merge over our B stream. And as before, let's create another channel merge and add the alpha of this patch to our master alpha. I think this patch is noticeably a bit brighter than its surrounding sort of pixels. So let's put a grade node before the roto node, and let's drop the gain a little bit. Cool. This method of cleanup works really well if you have a flat area with no texture, such as a green screen, or with a repeating texture like a brick wall or something like that. One advantage of this sort of method, as well as any other live method, and I mean live as in it's not a static frame hold, it's continually resourcing from the plate on each frame. And the advantage to that is that any lighting changes or increases or decreases in brightness that take place over the course of the shot are going to be accounted for. We're not going to have to set a whole bunch of keys on a grade node. We might just have to make one adjustment that will work for the entirety of the shot, such as what we've done here. One disadvantage of this method is that it's going to cause repetition, so far as that's going to be an issue. On this shot, it really doesn't matter because the entire green screen is going to get keyed out anyway. But you can imagine if, say, this is a wall with sort of a random organic texture, like it has cracks running up and down it, and if we use this method, it could result in some pretty obvious repetition. Another thing we should probably do before we move on is think about how we're going to bring Iron Man back when he passes over our paint. And also how we're going to fix the edges where the marker is showing through the edges of Iron Man, such as here. What we're going to do is, whenever any part of Iron Man is over our paintwork, we're going to deactivate the paint. And you'll see why we're going to do this shortly. So for this marker here, we're going to deactivate the paint on frame 26. And we'll do that by keying the opacity off. So let's set a key at frame 25 when it will be on. And then step forward and set the opacity to 0. So frame 28 is the last frame we want it to be deactivated for. So set another keyframe and then let's turn it back on from frame 29 onwards. So let's look at what that's doing. Now for the frames where the markers are showing through the motion blurred edges, we're going to do some edge fixing here instead. And I'm going to show you guys a few techniques for doing that too. But for now, let's just focus on the markers. And once we've removed all the markers, we can then look at fixing up these edges in as tidy a way as possible. So let's label this one and move on. Okay, for this next marker here, we're going to use a method that can be used as a way to sort of get around the problem of repetition when it comes to sourcing from the plate. And that is the clone tool in the Roto Paint node. So for this marker, we're going to create a Roto Paint node and we're going to paint up one frame. So let's step through the timeline and find a good frame to paint up. And we can see that this frame here is probably going to give us the most trouble when it comes to cloning from nearby. So if we paint up this frame, it should work on all other frames. The other thing to consider is that this marker is going to leave the frame, so we need to source from below it. Otherwise weird stuff is going to happen. It's going to start trying to source from outside the frame. So let's clone from below the tracking marker. So let's select the clone tool, let's set the lifetime to all frames and set a low opacity and let's start painting. So that looks good, except that because of the gradient of this green screen, I think this side of the patch is too bright. So let's source from the other side of the marker as well to counteract that. And I'm going to turn build up off so I can do this in very small increments. And we can always do a blur on this as well, just to even it out. We need to adjust the lifetime of that stroke since I forgot to. Now the next step is to track this marker, so let's do that now. So it's going fine until the hand comes up here, and then it gets a little bit wayward. So let's just manually fix up those frames. A good way to do that is to enlarge this viewer here, and then just step through using the arrow keys, and on each frame you can just nudge the tracker using the number pad. So one nudge is 1 pixel. Unless you hold control, and then it's a 0.1 pixel nudge, and if you hold shift and nudge, it's a 10 pixel nudge. And this viewer here is great because it's stabilized around the tracker. So if you step back and forward with the arrow keys, you can notice even small flaws in the track. Cool, so that looks fine now. Now we just track forward, and then once it's left the frame, let's just manually move the tracker outside of the frame. Cool, and inside the tracker node we need to set the reference frame to the frame that we painted on, which is frame 18. And now let's link the tracking data to the root this time, because the root holds all of the strokes. Now let's duplicate the tracker and set it to stabilize so we can QC this. And that looks great. So this method has the benefit of being a live method. So it's resourcing on each frame, so any changes in lighting on the plate are going to be accounted for. But it also gives you the freedom of being able to paint it so as to ensure there's no repetition or anything like that. So let's label this one and move on.